My name's Dave Sweetman from the Dialog Group, and today I'm going to be talking about EV testing with the DL9130EV, which is the latest multifunction tester from Dialog. So before going any further, I'd just like to introduce you to the Dialog Group, because Dialog is now a group of companies. From its founder division in 1998, Dialog Test Equipment was formed for supply of electrical test instruments to the UK electrical market for electrical safety testing. But Dialog as a brand has been around for a lot longer than that. It's been around for over 40 years actually, and if you do look hard enough you can find some of our equipment from many years ago. But we are a group now, so we're more than one. So in 2005 we introduced Recal calibration, and Recal was formed to monitor and track and support the service division for Dialog test equipment originally, but we've obviously since branched it out to look after other manufacturers worldwide. And that looks after mainly service, calibration, all repairs and all updates to ours and other products out there. Instrument hire we launched 6 years ago, and the clue is in the name. So we hire electrical test equipment from all worldwide manufacturers, and that will be more specialist equipment like energy monitoring equipment, cable location equipment, thermography, and all sorts of obscure items that are very expensive to buy that you might only have one application for, and we enable that range to have easy access to you to use. And more recently, Dialog Energy, obviously with the latest energy crisis that's currently going on in the world at the moment. Dialog Energy covers a multitude of products, so energy monitoring and energy quality or power quality is one item that division specialises in, but we've branched out more into thermal imaging, so thermography, more about energy efficiency in your home for example or in buildings, and that also covers Dialog Solar now, which is our renewable division that's been in the market for around about 11 years now. So that looks after solar PV and solar thermal. But just to give you a little bit more information about Dialog as a brand, it was one of the first companies in the UK to launch a multifunction tester called the FIO240. Those of you who've been around long enough, longer than I've been with Dialog, and that's 22 years, you might have come across this. But I do actually own one of these. Not quite sure why, but it seemed to be a bit archaic, and I felt that I should buy it when I saw it come available on eBay as well. But we were also one of the very first companies to offer low current loop testing. There's only very few of us at the very beginning that offer this in technology, but it's the technology that's used today for non-trip loop tests. It enables us to basically perform a loop test without actually tripping the RCD. And I believe we are the very first company in the UK to offer auto switching voltage and continuity testers. So all voltage and continuity tests that you use today, which means that you can switch between continuity and straight onto voltage, we was the first to introduce that technology into the UK. But one of the biggest parts we are very proud of is that we do support British manufacturing where we can. Unfortunately, we can't produce all of our products in the UK, but we will try where physically possible to enable us to do this as well. So all our electrical safety testers, including multifunction testers and PAT testing equipment, is all manufactured in the UK. But we're going to talk about the DL9130EV, which we launched 2 months ago to service the UK market for people that are currently installing EV chargers or are looking to future-proof themselves to have this technology within the tester itself. And we'll talk a little bit more about why we've introduced different safety features and why this makes it an EV tester over a standard multifunction tester. But just to give you an idea of the functionality and the concept behind this, and testers that the predecessors to this as well. So we wanted to keep it simplistic. You've got a clear, as you can see from the exploded view of the tester on there, you've got a clear round test button that's quite clear if you need to press test. It's quite obvious, that's where you press test as well. We've also got 4 functional keys, and these change depending on what function or what setting you are within the tester itself, but the screen clearly indicates exactly what this button does as you rotate the dial around. On the very top of the instrument you've got 3 inputs, 4th if you include the remote test probe in that, so you've got red, green and blue connections for live, earth and neutral. And on the right hand side of the screen here you'll see a rotary dial. And the concept behind this is it's all in a logical sequence, so from the off position rotated anti-clockwise to the left, continuity, insulation and voltage is the sequence that you would do a standard test sequence or EICR report from. So you start with continuity, form the insulation, look for voltage, and then you rotate it to the right where you've got your live tests, which includes your fault loop impedance at high current and non-trip. And finally you've got the RCD test functions, which has got an auto RCD test, but it's also got our latest auto EV RCD test as well, which again we'll talk a little bit about that later on. But none of this would be possible without an EV adapter. All EV adapters are built and designed to an international standard, which basically means that they mimic what an electric vehicle would tell a charger. So if the vehicle wants charge from a charger, it will send a specific signal out to say, I want charge, or do you want to lock my charge lead in? All this information is done from the EV adapter itself. So it's basically a vehicle, or the same message as a vehicle would send to an EV charger. And it's got several functionalities, including enabling you to plug your multifunction tester in it to perform live testing. However, it is a standalone tester itself, or checker, so that it will indicate things like proximity pilot, which is the lead resistance. So each EV charge lead will have a maximum current capability, and that can be set within the EV charge adapter, so you can test that an EV charger is not going to overrate the lead that it's plugged into. It knows, or the EV charger will actually know what lead's plugged into it from a signal within the charge lead itself, and the EV adapter will simulate that as well. But control pilot is the main communication that you will use between the EV adapter and the EV charger as well. So each particular setting, so you can't see it from this diagram here, but what I can do is show you from this angle here. There's an EV adapter there as well. So you've got control pilot states A, B, C, which relate to non-vented charging, and then you've got a D, which is for vented charging itself. And each one of them letters has a different meaning basically, and just to make it absolutely clear, you can just about see it on the screen here. And without me looking to point at the screen, you can see the actual sequence and the definitions of this EV charge adapter are actually on top of the EV charge plug itself. So if you're not quite sure what position A and B is, you can quite clearly read that as well. So position A, for example, is EV not charging and not ready. Control pilot position B is EV connected and not charging. So when I say connected, this is testing the mechanism that locks the charge lead into the charge adapter and the charger itself. So you're not going to plug your vehicle in and your nice expensive lead go missing when you return to your vehicle. So that's an important feature. It also means that you can't disconnect that lead from the charger whilst under load, which is quite important really, because you've got high currents passing through these, and if you disconnect it all of a sudden, that could cause that could be a potential safety risk as well. And position C, which is the more common one that you'll see for charging as well. So this is EV connected, non-vented and ready to charge. So this in effect will be the signal the vehicle will say, thank you Mr. Charger, I would like to receive some charge please for my batteries, which are depleted at an expensive rate per kilowatt, I'm sure, if you use one of these rapid fast chargers out there as well. But other features on the EV adapter itself, you've got CP error E, which puts the control pilot mode into error, so the vehicle error in effect, and that's just stop and disconnect the charge. You've also got PE error, so if the earth disconnects or becomes disconnected at any point during the charge sequence, the charge will be aborted and won't continue. And most importantly, you've got a PE pre-test, which is a little contact electrode on the very, very top of the instrument, and this indicates if the voltage or the potential voltage between neutral and earth does end up above 50 volts. So by placing your finger on that, it will enable you to indicate that the earth that has present, and use the test to earth for you to actually indicate if there's a potential risk as well. But each of these tests and indications are all identified on the very, very top of the adapter there. So we're going to put all this together, and we've creatively called it a DL9130 EV kit. Possibly could have been a bit more creative with the part number there, but it gives you it's quite clear, it's quite precise that it becomes together with both components become our complete EV testing kit. And that's what we're going to look at during this session. So why do we need to test? I'm not quite sure why that camera is on there, but I'll remove that from the screen. So BS 7671 section 643.10 titled functional testing. So equipment shall be subject to functional testing. That includes switchgear, control assemblies, systems for emergency switching off and emergency stopping, insulation monitoring. But obviously this is not exhaustive. So how far can we take this? So if I'm just going to read from, there you go, I'm sure most of you have a copy of this as well, and I'm just going to read this short paragraph which should hopefully tell you exactly what I'm trying to achieve by this particular session. So equipment shall be subject to functional testing and as appropriate to verify that the properly mounted, adjusted and installed and operates correctly in accordance with the relevant requirements of BS 7671. And I've just read them examples that you can see on the screen there. But it also goes on to say protected devices shall be submitted to a test of their function as necessary to check that they are properly installed and adjusted. Where fault protection and or additional protection is provided by an RCD, the effectiveness of any test facility incorporated into the device shall be verified. So what does that actually mean? So, and just to explain it slightly, the EV charger is actually protected by a sub-distribution board in most instances, and which is protected by a Type A RCD. So this is DC sensitive or DC half wave rectified, however you want to call it. So this will actually trip out on standard AC, so you get 30 milliamp imbalance there. It will trip out on AC current, and also it will trip out on DC current if 30 milliamp is detected within that RCD. But the EV chargers themselves have got their own internal protection, so they call this RDCDD, which is residual direct current detecting device. And they've been very, very stringent on what they've actually set this to. So the EV industry has set a standard that all EV chargers that don't require stake connection with it as well, which is most out there at the moment with the pen detection, do not require an earth stake. So they have what's called a 6 milliamp DC protection in them. And what that basically means is if the EV charger senses more than 6 milliamps leakage, so that's an imbalance of some sort, so it could be leakage to earth, it could be anywhere, then the charger will stop charging. So this, you could say, is a functional safety test within the EV charger. So we believe, and all manufacturers are of the same opinion, speaking to some colleagues in other manufacturers who are friends of us at Dialogue, all in the same thought really, that this should be a test that is integrated into a process when testing EV chargers. And we're quite adamant that this is the way forward, and this really should be done, or at least considered as part of your installation process. So what have we done? What have we changed in our equipment and other manufacturers to actually make them into EV testers as well? So we've introduced a 6 milliamp DC, a pure DC RCD test into our latest product, which is the DL9130EV. This in effect simulates exactly the same test an RCD, how we would test an RCD. So we would look at the imbalance or the 6 milliamp imbalance between the currents that are monitored within the RCD, and we'll simulate that imbalance, and that will give us a trip in time. Okay, so the trip in time that the 6 milliamp or the RDC DD 6 milliamp test should be is it should disconnect within 10 seconds. So that's quite important. So it makes it a little bit over the standard RCD test that you would normally do, whereas that's generally set a standard AC RCD at 300 milliseconds, for example. So we've extended the standard state that should be up to 10 seconds. So we simulate that. So we'll just basically do an RCD test at 6 milliamps DC, and we'll test that on the 0 and 180, exactly the same as what we do to a conventional RCD. And that's a proper test embedded within that. So that can be done independently, or it can be done as part of a sequence. So I've been a little bit creative here. So as part of our RCD testing sequence, so auto RCD test, which is set standard as you would be testing any conventional RCD, what we've got is an EV mode. So you can see next to function 1 on the top of the screen there, it says standard RCD. If I press F1, just put my finger over the top there, we can switch it straight to EV mode with a press of a button. And that automatically defaults to 6 milliamps DC. That's our DC DD test. And the tester is ready to start the test. However, if you have got a 30 milliamp, or if you've got a type B, a conventional system which is earth state, or a type B RCD in there, you can just press F4 and that will switch it to a DC 30 milliamp test. But we're looking at 6 milliamps DC, and what we're looking to do with this is actually run a complete testing sequence. So we'll check the DC side at 6 milliamps on the EV charger, and then we'll run the AC tests through the Type A RCD on the sub-distribution boards, and at the end of it we'll have a complete sequence which we can recall on the tester.
Right, I'll start the sequence.
So this will take a little bit of time to move through, and the reason it's taking a bit of time is the fact that the EV charger takes a little while to reset once it's been tripped
6 milliamp RCD DD.
So I've got it plugged in with the EV adapter into the EV charger, and I've pressed test. So you can see on the screen it's conducting the 6 milliamp DC tests. What you will see also on the screen is the combination of A and C flashing next to the vehicle. So that's prompting you to rotate the control pilot switch from between positions A, which is non-charging, to C, which is ready to charge. And so that in effect resets the EV charger each time. So as you can see, the sequence has already completed the 6 milliamps test, and we've already moved on to the AC side of the Type A RCD that's on the sub-distribution board. So I've simulated with a sub-distribution board next to the tester there as well. So we're doing the 0 and 180, the half, the 1 and the 5 times. You may ask, well, BS7671 does actually state that you just need to do the 1 times. But for the length of time this particular test takes, we believe, and all manufacturers believe, I'm sure they do, I'm sure others may well comment on other seminars that will precede myself, is that we recommend for the time it takes for it to be done, it's good to know that your RCD isn't tripping on the half times, and it's good to know it trips super quick, less than 40 milliseconds on the 5 times test. It's a part of a safety feature that we just strongly encourage you to do. But don't forget that BS7671 is the minimum standard. If you do more, then that's absolutely great. So this sequence will run 6 milliamps DC, then it will do the 0, 1 and 5 times on the AC side of a Type A RCD. And at the end of the sequence, when it's completed, you'll have the option to do a ramp test. This is an optional test. So the sequence will finish in a couple of moments when this EV charger resets. You might be thinking how I'm doing that sitting here as well, but there's a video recorded earlier that you can see on the screen that will show the sequence being tested. Okay, that's the final one. So I'm just switching that back from position charge point control pilot A to C. It's picked up the voltage and it's tripped. Okay, so at this particular point I can press F3 and it will recall my results on the screen. Or I can continue to do a ramp test. So the ramp test is a test that's always been within all multifunction testers for a long time. So this, rather than tripping time, it gives you tripping current. It's quite a good idea for this because a 30 milliamp RCD, most of us know that never trips at 30 milliamps. It's always lower. It's 21, 22 generally. You know, if it goes over 30 milliamps, then you're in trouble. And if it's under, it's absolutely fine. If it goes too far under 15 milliamps, for example, then that's not great. You're going to get nuisance tripping with that as well. So whilst we're at it, we're going to do a ramp test. And what I said at the very beginning of this is the test needed to be conducted over a 10-second period. So the protection within the EV charger needs to have at least 10 seconds to actually enable it to stop the charge on the EV charger as well. So we're just looking at, we've proved it already that it's well within that time, and now it's just checking the current that's tripping out. That was just about 4.46. I can't remember. It's well within its parameters. And as you can see, it does count. It does take a while to count up because it does need a little bit of time to actually engage the ramp test. There you go, so it's done the 6 milliamp side ramp test, and now we're just going to simulate 30 milliamp ramp test as well, so 21 milliamps on there. And I'm going to assure you, please bear with me, this is the last test that I'm going to demonstrate. This has gone to the extreme. Obviously ramp test is optional, you don't have to do this, but I wanted to give you an idea of what the tester's full capability is. There you go, the EV charger is reset. I'm switching it from control pilot A back to position C. And it will conduct the final test at 24 milliamps on that as well. Okay, and that's the sequence complete. Okay, so what you'll see is that pressing function 3, I can then recall all them results individually. So if I run that, should be able to run that again. There you go, so you've got 0 and 180 on the 6 milliamps, you've got half at 0, half at 180. You've got 0 at 1 times, 180 at 1 times, you've got 0 at 5 times, 180 it as well. And what I can just do very, very quickly is just recall that on here as well. So there you go. So here you've got your results by pressing function 3. You can see all the recorded test results in there. So what you'll also notice is the screen goes from blue to green. So if we have put pass-fail parameters within this as well. So if they do trip out of the parameters that are set internationally, that it would indicate clearly. So for example, I've got a ramp test there at 21 milliamps, and as you can see for this exercise that I did with this, we delayed the tripping time slightly, and a 30 milliamp type A RCD on AC test tripped at 33 milliamps, which is over the permitted requirements and that as well. So you can see at any part of the test goes red and indicates a foul. So that's the sort of testing sequence we've introduced onto EV testing. Obviously, there is more to it. I'm specifically talking about the RCD testing and the RDC testing side of it as well. But like any electrical appliance, it's obviously stringent to other standards. So, you know, the insulation testing, the continuity, fault loop impedance testing all still apply as if you are testing any appliance on any installation, that as well. But moving not too far off EV testing, there is a few functions that we've introduced to the 9130EV in addition to anything that we've done before, and others as well, in all fairness. So On the continuity side of it, on the continuity testing as well, which as you can see is a clear indication down to there as well. You've got a secondary display, so when you perform a continuity test, the results drop down onto the bottom part of the screen. So you can see I'm connecting up there, and the testers are on fully auto sensing, so the minute that it sees any particular current, you can see it indicates on the screen and drops down to the second part of the display and holds it on there as well. But if you do apply voltage to any of our dead test functions, like any tester on the market, they have to indicate voltage and they'll have to inhabit any test as well. They're not the same. You can't quite hear this at the moment, but the tester does make a horrible screech to say you put voltage on me when you shouldn't have done, and the screen does actually turn red. But something new we've actually done with the tester is actually introduced a system called RMAX, which is very, very similar to ZMAX, so which will automatically capture the maximum R1 plus R2 resistance or R2 resistance as well. So this is when, for example, doing a ring final where you've looped out your live and earth at the distribution board, obviously once it's safely isolated, of course, and hopefully it'll be a new installation as well. So the idea being is that you can check polarity across all your sockets and you record the maximum R1 plus R2. And this is quite important for the ZS calculation, because we all know that ZE plus R1 plus R2 equals ZS. So it's very important that you know what this is, one, to record in your EICR reports, and to have an idea of what your earth fault loop impedance should be at the end of it as well. So RMAX will, as like what ZMAX is really, it will track the maximum continuity. So if you use your 13 amp plug or your socket adapter to plug between live and earth and conduct the tests, what it will do is essentially track the maximum resistance recorded on there. So I can just simulate this on a checkbox. It will always go to the maximum, so you've got 1 ohm there. But if I start going back the other way, closer back to the board where the resistance will be coming down, you can see the maximum R1 plus R2 is already recorded. So that's obviously on a ring main. If it's a radial circuit, you would do exactly the same again, but testing at light fittings or light switches, and you can go furthest away and find the furthest point. Generally speaking, if you've done the installation, you'll know where that is anyway, but it's good to know what is the maximum. And if you're anything like me, when you do a test and get a particular reading and then do the next test, you've already forgotten what the result was from the previous one as well. So this is a very, very useful feature for people with memory like myself. So insulation test, it's an insulation test. It's an insulation test. We have got some safety parameters on here as well. Performing the test, it run a 5-second test. 3-second test at 500 volt. Then it will give you an idea. If you want to run it for slightly longer, you can just press and hold the test button, and it will run it for as long as you want to hold your finger on, really. If you don't want to hold your finger on, you've also got a lock option as well, which will just run the test until, and hopefully, continuously until you stop it as well. But what it has also got as a safety function as well, if the value or the results drop below 1 meg, okay, the test will also indicate by the screen going red and set you into alarm mode. So voltage testing on there, it's fully auto ranging, AC/DC up to 480 volts, may I add as well. So you've got quite a lot of safety protection for any sort of any voltages that are above the standard 400 volt 3-phase you'd expect between phases as well. So you are fully protected on this as well. So for phase sequencing, which is part of what the tester have got, and all our testers have had previously to actually as well. So it requires obviously all 3 connections on there between L1, L2 and L3. You can see I'm simulating that there. And it will then indicate voltage, and then L1, L2 and L3 will appear. If they're in that order, the phases are in the correct sequence. If there's any other sequence, they will not be in that sequence, if that makes any sense to you. And again, other standard functions within our tester. And again, some new features that we've introduced as well. So we've got 2 and 3 wire loop testing at high current as well, but it's intelligent, so it knows whether you're using a 2 or 3 wire connection as well. So by using either 2 wire between live and earth or 3 wire connection, the tester will say if it can safely take the measurement and it's got a path that it can take for that particular measurement, it would do it automatically, and there's no switching between 2 or 3 wire. It's intelligent, it knows exactly that as well. So we're set for prospective fault current. Press F1 for prospective short circuit current. That's tested between live and neutral, or fault current between live and earth. Similar to non-trip on there. It's a 3 wire test that we conduct with the non-trip loop test, and again that has got a fully auto start function, so providing that Z auto is on the screen, which you can just about make it out, it is there and it's all plugged in and connected. You can then perform the loop test very simply and very, very quickly, multiple times, or as many times as you want, really. There you go. A new feature we've introduced into the new 9130 specifically is RMAX as well. So this will track and automatically record the maximum loop testing as well. Very similar to, well, actually it's where we got the idea for RMAX from, actually. So you're going around the sockets, doing multiple loop tests on each one to find out the furthest point, so that you're really looking for the maximum resistance on either a radial or a ring main to record your ZS. You can see 0.26 is then takes a couple of seconds to capture that as well. And the last function we've introduced onto the new range of testers is variable RCD test as well. So you can see by pressing function 3 and 4, you can actually scroll up and down and set your parameters. So once variable RCD is set, you can jump to this preset test parameter from any of the other tests. So you could be on 1 times test, press F3 and it'll jump straight into 33 milliamp RCD or 68 milliamp RCD, however you want to do it. You can pre-program whatever you want. So if you are testing to, sometimes you've got European spec RCDs which may require a 50 milliamp test. You can do that, and if you want to do a 5 times test based on that, you can do a 250 milliamp test. It's absolutely fine. Okay, well, that's me talking long enough. Thank you very much for listening, and I hope that's given you a bit of an insight to what we're doing as a business for EV testing, and how we're working with friends out there in the marketplace. You know, with lots of electricians we've spoken to that are conducting EV testing, or have been doing for many years actually. But our ultimate objective really is to produce or manufacture equipment that's simplistic, not complicated, does what you need it to do, and create what we believe to be one of the most comprehensive multifunction testers for the price on the UK market. So we're going to take a few questions and answers, which I will take off this particular presentation. And what I'll do is I'll post this in the chat as well, so you can list all the questions that are being asked, and then based on what we've said so far, and then we can have a talk about all the questions, or I can try and answer the questions at least anyway. But please keep in contact. Obviously, here are the group divisions. So from any of these websites, you can redirect, you can navigate to any of these websites as well. So if you're on a Dialog site, you can look at Rico, Instrument Hire and Energy, and vice versa and that as well. So you've got all the information about what we are, who we are, what we do as a group. And please keep in contact. Follow us on social media. We're on all the social media platforms, including TikTok now, which isn't on this display. We're moving with the times, yet. I haven't done anything overly creative yet to fit into the TikTok world, but myself and my colleague are working on it. But I'm here for you to contact me directly. If there's any questions you have regarding any of the information or topic on this presentation, if you can't think of any questions now, but some crop out later this evening when you're at home, or the afternoon, or when you're at work, or even when you're testing, something happens, something crops up, you need to find out more information about what's happened and what you need to do to test this particular device, please keep in contact. The details are down here. So email address and mobile there as well. And again, you can contact myself and my colleague and multiple colleagues within the group on social media as well.